Hello, and welcome to the Convenient Carrier Design Challenge. I will be leading you through this activity. My name is Megan, and I'm a recent graduate from the Worcester Polytechnic Institute in Worcester, Massachusetts. I graduated with a bachelor's in robotics and mechanical engineering. I'm an incoming Mechanical Design 1 engineer on the OARM team at Medtronic in Littleton, Massachusetts. What is an engineer? You've probably heard a lot about engineering and STEM through your studies and through your time at the Girl Scouts. But do you know exactly what an engineer does? This is a really tricky question because engineering is a very broad category of careers. One definition of an engineer can be found below. It states that engineers, as practitioners of engineering, are professionals who invest, design, analyze, build, and test machines, complex systems, structures, gadgets, and materials to fulfill functional objectives and requirements while considering the limitations imposed by practicality, regulation, safety, and cost. That's a big mouthful. But basically what it's saying is that engineers are able to design things that don't yet exist, while having to obey the laws of physics and make sure that we are able to keep everyone safe who's using it and cut cost. This is still really broad. And as you'll discover, hopefully, as you learn more about engineering, there's a good reason for this. Another way to think about it is that engineers come up with things that don't yet exist, and it helps make people's lives better. Today, we're going to be focusing on one problem that you may choose to solve as an engineer, and that's accessibility. You've probably talked a lot about accessibility already. As you know, some Girl Scouts and people around the world have other challenges that they have to overcome, such as being paralyzed or having limited mobility below the waist. We will be focused. There are also other accessibility concerns, such as people who experience blindness, deafness, and other disabilities, but we will be focusing on limited mobility today. Specifically, the problem that some people with limited mobility may find it difficult to carry personal items and retrieve it for themselves. Currently, most traditional ways to store and carry objects are not designed for wheelchair or crutch users. This can make it really difficult for them to do what they need to and can take twice as long as someone without a wheelchair or a crutch. At this point, you may be thinking, what can you do? As an engineer, as the engineer today, you're going to be coming up with some challenge with a device that is going to work better for these individuals. As we're focusing on limited mobility, you will have two choices. You can either create a carrier for someone who is in a wheelchair or who uses crutches. You do not have to decide at this time. To complete this challenge, you will need a team of 3 to 5 passionate Girl Scouts. We recommend that you do this activity in a team, as teamwork is essential to engineers and will help you come up with a better solution. We recommend that you do not have a team of bigger than 5 Girl Scouts, as the teams may get too big and it may be hard for everyone to contribute meaningfully to this project. You should also have wheelchairs or crutches so that you can test out your invention. If you do not have the access to a wheelchair or crutch, there are other things you can use to test it out and to simulate these. For this activity, we wanted you to have as much freedom as possible when it comes to materials, as long as you're keeping the cost low. So the materials are up to you, other than those first two, and these are just suggestions. We recommend looking into getting multiple types of cloth, which should include felt, quilting cotton, flannel or knit, sewing supplies, corrugated cardboard, Velcro, plastic solo cups, yarn or rope, tape and glue, and air dry clay. As you go through the design process, you may decide that you want to add in more materials, which is fine as long as you have a way to get them. For your requirements, regardless of whether it's being used by a wheelchair or crutch, it must be easily accessible so that the user can get anything in and out of the bag in little time. We want the bag to be big enough to hold a textbook, binder, and a few other small personal items like you may need in a class to take to class. It should be relatively cheap to make because while we're letting you use any materials, we don't want you guys to go overboard. And we want this to be part of accessibility is that the cost does not prohibit those who would like to use it. It must be durable and withstand rain and constant use, so you may want to do some water testing. As you do more research, you may also determine other criteria as you go. To do this challenge, you will be using the engineering design cycle as seen here. The first thing you're going to need to do is identify the problem. We've helped you do this a little bit, but we'll have some activities to help you further narrow down the problem. You'll need to brainstorm and design, which we will lump together for the purpose of this activity to speed up the process. You'll also need to build, test, and evaluate and redesign, which will go through your prototypes cycle. And at the end, you'll need to share your solution with those who could benefit. The first step is to identify the problem. We have created 2 activities to help you identify the problem. If you are planning on designing for a wheelchair, you will have this activity to complete. You'll either need a wheelchair or to use standard chairs to complete this activity. Before starting, you need to fill a standard backpack with 4 distinct textbooks, as well as other school materials. Everyone participating in this activity should be using the same textbooks and materials. You'll have one teacher who can be a volunteer or another Girl Scout who will know what is in the book bag. They will decide what the students need in order to do their activity. Without leaving the chair or moving your bottom half, you will need to get something out of the book bag, and you should record how long it takes you to do this. You should also test putting things back in the book bag. If you are using a Girl Scout as the teacher, they should have a chance to also do the activity. Make sure you do this multiple times and see if there's ways for you to improve your score. If you're looking to design using crutches, you will do this activity. We suggest you use real crutches, but if you don't have real crutches, you can use rolls of newspaper or paper under the participants' arms and stand on one foot to do the simulation. Before starting, prepare a lunch tray or large plate. On the tray, you will want to have 1 large cup of water and you want to fill it to the brim with water. You will want to pass this tray around to each of the participants and observe the amount of water that spills out of the cup. Try to do this multiple times and see if you can get as little water as possible to fall out of the cup. Once you have done the activity, you can come back to this video, but for now, pause. You have now completed the activities. It's now time to draw conclusions to help you identify the problems associated that you are trying to solve. Here are some recommended questions from us. What challenges did you have to overcome to complete the task? Did you find any hacks that made the challenge easier? What are some things that could have been changed about the challenge to make these tasks easier? Take some time now and pause this video to discuss this with your fellow Girl Scouts. In addition to doing this activity, you may want to do some additional research. Here are some additional research ideas you may want to look into. Talk to a wheelchair or crutch user. Look at existing designs for similar projects. Create a survey for wheelchair and crutch users to gather data. Look for limited mobility support networks. Read stories of girls with limited mobility, and learn about disorders that may lead to limited mobility, like spina bifida and cerebral palsy. Pause this video now while you continue your research. Now that you've completed your research and understand the problem, it's now time to go on to brainstorming and design. Before we do, we want you to take some time to talk about special skills that may be able to help your team. Because this project uses abnormal material, some skills that you might not commonly associate with engineering may be extremely useful and vital for your team's success. So it's important you share all possible skills that may benefit with your team. Some ones that we think might be especially beneficial are sewing, crochet, pottery, or electrical skills like soldering and basic circuitry. Now it's time to get designing. The first thing you want to do is use pen and paper to sketch out possible ideas. As engineers, it's really important that we are able to communicate our designs with other engineers, and pen and paper is one of the oldest and most useful ways to do this. It's important to remember at this stage there are no bad ideas. And there can even be merit in coming up with some crazy ideas, because through those crazy ideas, you may find a really useful and great idea. It's also important to remember everyone's idea is heard. Once you've done this, as a team, you're going to pick one idea to go forward with. On a real engineering team, you may choose multiple ideas to go forward with and prototype, but because of the small team sizes and the limited time, we only want you to choose one. Once you've picked your design, you're going to need to add a lot more more details, like about materials, any necessary requirement, and any necessary measurements. Pause this video here while you complete this section. Once you have decided on your design and fleshed out the details, we recommend that you have an outside volunteer look at your project. Design reviews are critical in engineering because sometimes it takes an outside opinion to notice something that your team may have missed, as you may tend to fixate on the design and miss bigger pictures. Pause now while you get outside volunteers to look at your current designs. Now that you have finished your design stage, it's time to prototype and test. You're probably excited to start building your prototype. Before you start, make sure that you have all the materials that you need for this design challenge. Because you are able to use any materials within reason, you may not have collected all the materials that you wanted initially. Once you get started, you will probably notice that your design doesn't work as well as expected. This is okay and is actually a good thing. This is why we have to prototype and test as engineers. Pause your video here while you prototype and test. Now it's time to communicate results. When you think of engineering, you probably think more of the prototype and designing stage. But being able to communicate your results is a vital part of being a good engineer. So, to create your presentation, you can use any of the following: PowerPoint, poster, video, or website, or maybe even a hybrid like this video, which goes through a PowerPoint. In your presentation, you're going to want to be sure to include a problem statement, the current solutions that are already out there, your design, and what makes your design different, and the big takeaways you got from this project. Pause now to make your presentation. Once you have made your presentation, you should present to your troop, your family, and if possible, your school and wheelchair and crutch users. At this stage, you may receive feedback and choose to make modifications to your design. This is normal and what real engineers do. Now that you're done with your presentation, it's time to wrap up. We have some suggested wrap-up questions to discuss with your team and other people that you may have done this activity with. These are by far not the only questions, and your troop leader or your friends may have more questions that you would want to go from. How did your final design differ from your original? Many people show the design process to be circular instead of linear. Why do you think this is? When doing research for this project, did you come across other challenges faced by individuals with limited mobility? How have engineers helped increase the quality of life for individuals with disabilities? Pause here while you answer these questions. Hopefully you enjoyed this activity, and you might be wondering what type of careers and what the activities like this would look like in the real world. If you are interested in this career path, one avenue you may consider taking is prosthetic engineering. As a prosthetic engineer, you're responsible for researching, designing, and developing prosthetics, mostly thought of as artificial limbs. If you're interested in helping increase mobility, a prosthetic leg may just be your avenue. You may also be interested in mechanical engineering. Mechanical engineering is the most broad of any of the engineering fields. Mechanical engineers research, design, develop, build, and test various devices. Some projects that mechanical engineers may work on include designing a wheelchair capable of going over difficult terrain, designing a more inclusive playground that can be enjoyed by children of all abilities, and designing more advanced prosthetics. The final career we will talk about is electrical engineering. Electrical engineering is an engineering discipline concerned with the study, design, and application of equipment, devices, and systems which use electricity, electronics, and electromagnetism. Some similar projects an electrical engineer may work on include designing medical devices like pacemakers, designing electrical systems that let people who are sight impaired know what is around them, and designing hearing aids. If this project was of interest of you, you may be interested and you would want to continue. Here are some ideas for project continuation. Research other accessibility concerns and design solutions for them using the engineering design cycle. Build a playground that is accessible to all in your neighborhood. Research a disability, either visible or invisible, and share your findings. And start an education campaign to teach others about how they can make their communities more accessible. Last but not least, I want to leave with this quote from Dr. Seuss. Unless someone like you cares a whole awful lot, nothing is going to get better. It's just not. And this is a quote from Dr. Seuss in the Lorax. It is about environmental science, but I think it's still very applicable here. As engineers, we have the ability to make the world a better place, but only if we're willing to see what's not yet there and willing to work towards it. Thank you, and I hope you enjoyed this design challenge.